Did you see those brakes take hold? Did, Mark. None of those foreign chops will do that. You said it. Listen. Wow! You want to try her? No. I'll get mine tonight, and I can wait. What time you getting her? We don't eat till about 6 o'clock. And being my birthday, Mom always has something fancy. Always takes a while longer. What time? Probably be about 8. All right, see you then. Okay.
Happy birthday, dear Jimmy. Happy birthday to you. All right, come on now, blow 'em out, blow 'em out. Oh.
Uh-oh, now you're not going to get your wish.
Oh, I bet you I am. I bet you everything I want is right here. Well, almost everything.
There's one way to find out. Start opening.
Okay. Wonder who this is from. It says from Grandpa.
That's right.
But I thought...
Well, it isn't what we talked about, but I got to thinking. You're growing up so fast, it's time I got something that would grow up with you.
Aren't you going to look at it?
Oh, yeah. I get it. It's a gift certificate.
No, it's a stock certificate. That means that now you're a part owner of a great steel company.
But I don't want to own any old steel company. I want a bike. And you promised, Graham.
That's enough of that.
But I
say that's enough. This birthday's over right now. Go to your room.
Oh, Dad.
Go on. I'm sorry, Dad. I didn't realize we'd spoiled him that much.
It's my fault. The boy wanted a bike and all he got was a piece of paper. Mind if I go up and have a word with him?
Go ahead. Then it will be my turn.
So you see, boy, steel is basic to our life. And when you're part owner of a sound growing company, you've got a share in the future of our country.
But it's just a piece of paper, Graham. How can it be so important?
That's a good question. Maybe if you'd write a letter to Youngstown, they'd answer it for you.
Who would I write to?
Oh, the president, I guess.
The president?
Why not? You're an owner. He's working for you.
He is? Well, then he better be nice to me. I'm sorry I haven't been very nice to you, Graham.
That's all right, boy. We understand each other now. Go get on with your letter.
Okay, Graham.
Mr. Glossprinter. I don't quite know how to handle the one on top. It's from a stockholder.
Oh, I see what you mean. I want you to arrange to have this young man come in for a visit and have Mr. Emery come in. I want to see that he gives this his personal attention.
I take it you're Jimmy Daly. I'm glad you could come. I'm Bill Emery.
I'm pleased to meet you, sir.
Have a nice trip?
Oh, yes, it was great. But I didn't mean to cause so much trouble.
We like to have our stockholders take an interest in their company. Well, where would you like to start?
Any place. You see, I haven't owned the company very long.
I understand. Well, let's start right here with these men who have run the company since Mr. Campbell there founded it in 1900. Now, it was rather small then, but today under Mr. Morphy, he's the chairman of your board, and Mr. Glossprinter, your president, it's the 7th largest steel company in the country and among the greatest in the world.
And it's all right here in Youngstown?
Oh, indeed, no. Our company has interests in all parts of the world. Let's go up to the conference room. I have the whole story laid out for you. decisions, mostly. The people responsible for running the mines and the mills work here. Now, it's also headquarters for the managers of sales, engineering, purchasing, accounting, research, and so on.
My grandpa said we have quite a progressive company. I guess this is what he meant.
And he was quite right, Jimmy. I think I can show you that. Make yourself comfortable there. Now, I'm going to show you what's behind that piece of paper of yours. You see, Jimmy, Youngstown is recognized as a growing force in steel. In the post-war years, our company has poured more than $700 million into building some of the most modern steel-making facilities in the world. Its capacity to produce steel has increased 65% in that time. And we're still building and growing. Today, Youngstown's ingot capacity is 6,750,000 tons, produced in 4 major steel producing centers. The Campbell Works along the Mahoning River, the Briar Hill Works in Youngstown, the Indiana Harbor Works in East Chicago, Indiana, and the South Chicago, Illinois Works. In these plants, we process raw materials gathered from our sources in various parts of the world. Natural ore comes from several sources. One of the newest is the Iron Ore Company of Canada's open pit mines at Shefferville on the Quebec-Labrador border. Youngstown is one of the steel company partners in this project. The ore is rich in iron content and can be used just as it comes from the earth. Other sources of iron ore which we're helping to develop are in the Wabash Lake area in Labrador. Here, a beneficiation plant upgrades the natural ore before it's shipped. A 350-mile railroad carries the ore from the Labrador fields to the storage yards and loading docks at 7 Islands on the St. Lawrence. It's 975 miles by water on Lake Erie, which is the unloading port for the Youngstown mills. Youngstown's ore interest and reserves in Canada and the United States assure the company ample supplies for decades to come. Another source of iron for the company's furnaces is the open pits of the Erie Mining Company's taconite plant in Minnesota, another company in which we have substantial holdings. Taconite in its natural state has a low iron content. The taconite is crushed and ground to a fine powder. The iron is magnetically separated from the rock and then made into pellets, which are about 60% iron. Youngstown was one of the companies which helped pioneer this process. The pellets are carried by rail to a high line above the loading dock. Belt conveyors transfer them to the ship. Ships like the J.L. Mothy of the Interlake Steamship Fleet carry the taconite pellets 820 miles to Indiana Harbor in 3 days. The 2 other basic ingredients of steelmaking are limestone and coke. Limestone is brought to the blast furnace site from quarries in Pennsylvania and Michigan. Youngstown's coking coal comes from the famous Pittsburgh seam, the most valuable mineral deposit in the world. This mine in Nemacolin, Pennsylvania on the Monongahela River is capable of producing as many as 7,000 tons per day. That's because modern, continuous mining machines like this one have taken much of the tedious, back-breaking labor out of coal mining. The coal is brought up from 200 feet below the river level and is blended and cleaned in a modern preparation plant before being shipped to Youngstown or Chicago. where the coal is converted into coke by baking it in huge ovens to drive off the volatile materials. After 17 hours of carefully controlled baking at temperatures up to 2,500 degrees, the hot coke is pushed out of the oven into a quencher car. And then, on to the quencher station, where water is poured onto the hot coke. Cool. It'll be screened for size and put on the stockpile ready for charging into the blast furnace. Now you'd think after going through all that trouble to assure ourselves of the finest raw materials, we'd be ready to use them.
Well, aren't we?
Not quite. You see, there's been a new development in the steel industry in recent years that saved a lot of money and resulted in greater output from the blast furnaces. It's called sintering, and we have one of the newest and finest sintering plants in the business. It's a tremendous complex of moving belts, ovens, and coolers. But it's an investment that pays for itself many times over. These are the storage bins that hold the materials to be sintered. From the control room, every operation in the plant is monitored and supervised. From 82 different checkpoints, information is fed into a data logging electronic computer, which instantly figures the optimum combination of materials, feeds and speeds, temperatures, and so on, that will result in the best possible product. The computer controls the rate at which each material is fed onto the belt. In the heat of the sintering furnace, the fine particles fuse together. Later, the mass is broken into smaller pieces. The last stop is the revolving cooler. The product is a uniform blast furnace charge produced at the rate of 4,400 tons every 24 hours. Today, the skip cars that charge the Youngstown blast furnaces carry 50% sintered materials, which results in greater production and better quality iron. The blast furnace operates continuously. Every 4 hours, iron that has reached a temperature of about 3,000 degrees is tapped off in one of the most dramatic processes to be found in all industry. The molten iron flows into a bottle car, which carries it to the open hearth, where it is transferred to the furnaces by means of a ladle. In the open hearth furnaces, the iron, mixed with selected steel scrap and other ingredients, is converted into steel. Of all the steps in steel making, this is the most critical. Steel has thousands of uses and hundreds of different specifications. In a heat of 312 tons, the melter must be concerned with alloys measured in pounds and calculated in terms of thousandths of 1%. The melter must know the exact percentages of sulfur, carbon, silicon, and phosphorus present in the heat. To determine this, samples are taken at the start of the heat and at intervals during the melting. Part of the sample is prepared as an electrode and burned in an electric arc. Each ingredient in the sample produces a different wavelength of light. The spectrometer measures them all and gives an instantaneous reading of the amounts of each element present. In the open hearth, some undesirable elements in the heat are burned away, and as the temperature rises, the carbon content decreases. This progress is carefully recorded. The heat is ready to be tapped after a few hours. The first helper taps the furnace by using an oxygen torch to burn away the plug. Then the real drama of steel making begins. Each ladle contains up to 312 tons of molten steel. It's cast into ingot molds, the largest of which holds 16 tons. The type of mold and the casting procedure varies with the type of steel being produced and its eventual use. After about 2.5 hours, the ingots have cooled and solidified sufficiently to permit removal of the molds. The hot ingots go directly into a furnace called a soaking pit, which brings them to a temperature of 2,300 degrees. The quality control engineers, who are thoroughly acquainted with every ingot, specify the exact time and temperature schedule to be followed in the soaking pit. Becomes a matter of reducing the ingot of steel into the product the customer wants to buy. Well, this is done in a series of steps. The first being the blooming mill, which reduces the ingot to any one of 3 rectangular shapes, depending on the ultimate product. One of the motors which drive the rolls of the blooming mill. 5,000 horsepower. Cost of the drive mechanism, $6 million. Reduced to slab form. take over the shaping and forming tasks which produce the bars, the rods, the rounds, and countless special shapes required by industry today. At Youngstown Mills, steelmaking is a matter of quality, precision, and endless variety. Daily production is measured in thousands of tons, but every order is special. Specifications are exact and are exactly executed. The company's reputation for quality with precision goes back more than 60 years and is known and respected wherever steel is used. And today, that's everywhere. Progress and research have become almost synonymous terms in today's world, and we think of them as one at Youngstown. In completely equipped laboratories, our research scientists can duplicate every operation in steelmaking, from raw materials refinement to hot and cold rolling. Grain structures of experimental alloys are studied under instruments that magnify the surface area 2,000 times. Hardness characteristics of metals and coatings can be determined with ultra precision. Thousands of tests are run on specially designed equipment to measure resistance to various kinds of corrosion and to test the effectiveness of protective coatings. The ability of steel to stand up under stress is important in many applications. Fatigue tests are conducted in the laboratories using experimental alloys. Promising formulas are tested later in full-scale production. Special projects often require elaborate and expensive testing. This complicated equipment is part of a program devoted to developing a corrosion-resistant steel for automotive exhaust systems. Yes, at Youngstown, research and progress go hand in hand. We know that the steel products of tomorrow will have to meet demands unheard of today. In our laboratories, we bring together all the resources of all the sciences.
You know, Mr. Emery, I bet you we got the best steel company in the whole world.
Well, let's just say we don't think there's any better.
I wish my dad was here. I don't think he knows about all this.
Oh, why do you say that, Jimmy?
Well, we've got a lot of stuff around our house made out of steel, but none of it says Youngstown Sheet and Tube on it.
No, but a lot of it might be our steel. You see, except for pipe and electrical conduit, we don't make the finished products you find around your house. Our customers do. Now, we never felt it made sense to go into competition with them.
What do we make then?
Well, products that only a steel company can make. Now, you remember those slabs we saw made in the blooming mill? Well, here's what happens to them. They're heated to about 2,200 degrees and then drop onto a roller table, which is part of one of the biggest and most complex machines in all industry, the hot strip mill. The Youngstown mills can roll strip up to 74 inches wide at a speed of up to 2,100 feet per minute, or well over 20 miles per hour. It's a continuous process, with the slab starting at one end and traveling nearly a quarter of a mile through 11 different mill stands before it emerges as a coil of stripped steel at the far end. Everywhere along the line, built-in devices are keeping watch over the process, holding tolerances, safeguarding quality. Information from all points pours into a master control panel, giving the operators an instantaneous report of everything that's happening all along the line. The temperature of the steel as it goes through the roll stands is all important to quality. Recording pyrometers provide a written history of every foot that races by. Coils up to 15 tons in weight and 2,200 feet in length can be made on the newest Youngstown mill, one of the fastest and most accurate in the world. In some cases, hot strip steel is a finished product. Most of it, however, undergoes further processing. For example, cold reduction. In this mill, the steel strip is reduced to specified thickness. The mill operates at speeds up to 3,500 feet per minute and holds tolerances measured in thousandths of an inch. Cold rolling hardens the steel, and for most uses, it must be annealed or softened. Now, this can be done by a continuous method or by means of a process called batch annealing, in which coils are stacked and then covered with a portable furnace. An inert gas protects the steel from oxidizing during the process. The temperature within the furnace is raised according to a very precise schedule to the specified level. For Youngstown sheet, a final temper pass is made to ensure superior quality and finish. Automatic inspection devices reject any defective sheets. The finished product has been under the rigid control of quality engineers every step of the way, from the open hearth furnace to the shipping floor. When the Youngstown label is attached to the product, the integrity and reputation of the company stands behind it. Another familiar Youngstown product is tin plate, the material from which tin cans are made. Coils of special formula cold-rolled steel pass continuously through a line that represents the ultimate in precision engineering. Traveling at 2,000 feet per minute, the strip passes from the cleaning baths on to the continuous annealing line. It loops through towers 70 feet high. After annealing, the strip undergoes a temper pass to prepare it for the tinning line. These coils, 8 miles long, will feed the tinning line. The line is a continuous process, and to provide time for welding the coils together without stopping, the steel loops into a pit 90 feet deep. The tin coating is applied by an electrolytic process, which distributes 1,000 pounds of tin evenly and uniformly over 30 miles of steel strip. The tin line has several automatic inspections and control stations, which constantly monitor the product and the process itself. The tin strip emerges from the line dull gray in color. It then passes through an induction heating unit, which melts the tin coating and imparts the familiar glossy surface. Laboratory tests are run continually to protect the product quality. Samples undergo dozens of chemical and physical tests to be sure that every order will meet the customer's specifications exactly. In an 8-hour turn, the Youngstown line can produce 130 miles of top quality electrolytic tin plate, enough for 2 million household-size cans. In the tube side of the business, we produce everything the world needs in the way of pipe, from 1/2-inch water pipe to 22-inch line pipe, including seamless tubing. For example, line pipe for the petroleum and gas industries. Line pipe begins as a flat sheet of steel. It is fed into 8 huge rollers which form it by stages into tubular shape. Just before the 2 edges are brought together, a powerful electric current heats them to a plastic state. Then a final roll presses the soft edges together, welding them into a solid union of steel. The weld undergoes immediate inspection, utilizing powdered metal and ultraviolet light, which detects even minute flaws. Every pipe is subjected to a water pressure test well in excess of customer specifications. Now, this is just one of a long series of tests that every length of pipe must undergo before it leaves the Youngstown plants to enter the service of industry the world over. Another Youngstown product, the pipe which is sent down into the world's oil wells, is subjected to some of the most rugged service man has yet devised for steel products. So we give the oilmen rugged steel, pipe that starts as a solid round and is pierced so that no weld or seam exists in the finished product. In the oil country, hundreds of thousands of dollars can be lost if a pipe fails. At Youngstown, we make sure that the customer's investment is secure. Every test known to science is applied to our oil country products, so that when we apply the orange band, we know that every length of pipe we deliver will live up to the Youngstown reputation for dependable, unfailing quality in the oil country. The same emphasis on quality is applied to everything that the Youngstown Sheet and Tube Company makes. Whether it be bars, rods, wire, pipe, electrical conduit, or any form of steel sheet. We know what went into it from the very beginning. We made the iron from our own iron ore. Our men watched over the furnaces that converted it into steel. We rolled it. We processed it. And when we put our name on it, 60 years of experience and integrity stand behind it. Well, Jimmy, that's the story. And so that you'll remember it, I've put together a few things for you to take home with you. Now, there's some booklets, some of our labels, photographs. And they're all here in this folder.
Gee, thanks. I'll show them to all the kids.
Good. Tell me, Jimmy, what do you think now about not wanting to own any old steel company?
How'd you know I said that?
Oh, we have a mutual friend. As a matter of fact, he's waiting for us right now. Come on.
Grandpa, I didn't know you were coming for me. You should have been here sooner.
Came as quick as I could. Had some shopping I had to do.
Did you find what you wanted?
Yep, just the thing. Left it over there. Go get it, will you, boy?
Go get? Wow!
Mr. Emery and I, well, we thought you ought to have a sample of one of your own products.
Gee, it's got everything. Even Youngstown steel.